Welcome, everyone. It's great to have you here. Thank you so much for taking time out of your busy schedule to join us today for our Ferroque Masterclass, Citrix Pod Architecture 101. Please join me today in welcoming Michael Shuster, CEO of Ferroque Systems, Nick Rintalan, Principal Architect and Managing Director of Global Presales at Citrix, Zeljko Macanovic, Senior Technical Architect, Todd Shu, President of Ferroque Systems, and myself, Amber. Hi, everyone. I look after the marketing here at Ferroque. Michael is the CEO of Ferroque Systems and a highly recognized Citrix consulting partner in North America, serving the role of an architect. Michael has sat on Citrix's consulting team for over half a decade and has led many of Citrix's most significant consulting engagements. He regularly contributes to Citrix's leading practices and documentation. Nick Rintalan currently serves as Principal Architect and Managing Director of Global Presales at Citrix. Prior to this role, Nick spent 17 years in various roles within professional services and customer success at Citrix. He was one of the pioneers of the Citrix consulting architecture team and ran the Enterprise Architect, or EA, team for 4 years. He loves debating best practices and architecture, and he's presented over 20 times on these topics at Citrix conferences and other industry events. Zeljko Macanovic is a leading expert on Citrix virtualization technologies with over 3 decades working with Citrix and Microsoft platforms. His knowledge in project delivery, technical considerations, and customer knowledge across industries is invaluable to each of our customers. During his tenure at Citrix, Zeljko sat on the CCAT board and contributed to the development of various Citrix consulting standards and methodology refinement. He remains a trusted and respected member of the Citrix community, both within and out of Citrix. And finally, Todd is one of the earliest pioneers of Citrix solutions in North America, who built one of the most successful Citrix practices in the world. His business was acquired by Citrix in 2012, after which Todd led Citrix's consulting organization in Canada for 5 years. Today, Todd joins Ferroque as both president and partner. Welcome, gentlemen. So what is pod architecture? Citrix has long been the leader in designing and building foundational infrastructure of the world's largest VDI and published app environments. As organizations grow their businesses, either from organic expression or M&A activities, they become increasingly mindful of failure domains, predictable scalability costs, and infrastructure requirements to support their growth. Organizations want a repeatable approach to expand their Citrix footprint. Enter pod architecture, a long-time strategy for modular building Citrix infrastructures that can scale while remaining sufficiently isolated to not impact other pods of apps or desktops in the event of a failure. Today, we will look at how to do this. Our panelists have designed many of the world's largest platforms, and they look forward to sharing their insights on recommended practices, technical and business considerations, and gotchas for Citrix pod design, accommodating tens of thousands of users to hundreds of thousands of users. Today, we'll start off by defining what pod architecture is, why and when you should use it, and what some considerations are you should look at. We'll look at the design principles and finish with a roundtable discussion. I want to thank you for coming again. If you have any questions along the way, please feel free to add them to the chat, and we'll be sure to get them at the end. So I'm going to hand things over to Nick to take things away.
Awesome. Thanks, Amber. Definitely excited to be here today to talk about one of my favorite subjects, the pod architecture. So before we get into all the technical details and some of the design considerations, thought it was important to first define, what a pod is and what pod architectures are and why we do them. So quite simply, a pod is a building block. I love doing Legos with my kids, and I think of I think of a pod as a smaller Lego block that then you put them all together and it makes up this very complex or sophisticated Lego masterpiece. But in the Citrix world, a pod is essentially a fully independent unit of infrastructure that represents, most typically a virtual apps and desktops implementation. So a CVAD pod might include the site, the provisioning infrastructure, the hypervisor and storage subsystems, and even like the SQL database. And we'll talk in a minute about where to draw the line and determine, what goes into a pod and what can live outside of a pod. But just think of it essentially as a mini deployment of CVAD that contains all the critical components and subcomponents. And once you build out a few of these mini deployments, or smaller CVAD pods, you essentially link them together to form what we call the pod architecture. So that's really in a nutshell. But why? Why do we go through, all this trouble of, building these smaller pods and linking them together? Because, you might be asking, it's easier and cheaper maybe to do one giant CVAD farm or site. Well, because in the real world, things fail. So I think as Amber kind of put it, right, we're trying to set up these smaller little failure domains to mitigate risk. That's what it's all about. And also we do these things because it introduces, what I like to call predictability, right? Which is, one of the main tenets of any good system is it's predictable. It's everything from not only the scalability or capacity, but also cost. So anyways, we sort of invented the pod architecture about, I think 15 years ago when it was one of our biggest Citrix customers, and they were approaching, I think it was about 100,000 concurrent users. And they were running everything in a single XenApp farm up to that point, right? So one farm, one database, one of everything. And what we started seeing happen was just strange kind of, things were happening. It just became a little fragile and unpredictable. And what I mean by that is, consoles would start timing out or taking forever to load. We saw unusual black holes in critical services like the XML service or even a license server, I remember. We saw, strange deadlocking issues with PVS and SQL Server. And when those things happen, it basically resulted in a giant denial of service for all end users. So like, 250,000 users in this case, or 100,000 concurrent that were on at the time. So not just one or two users, everybody's impacted. And that's the extreme case, right? And so we started to think about how do we minimize those widespread outages, And so we essentially landed on what became the pod architecture. I remember actually doing the re-architecture for this client. And what we did was we took their one farm and we cut them into 4, smaller farms. So each farm basically served 25,000, I think, concurrent users at the time. And then we took the one SQL database and cut it up into 4 SQL databases, right, to align with the 4 farms. And all of a sudden, consoles started loading quickly. User experience was consistent again. Most importantly, when they'd have like a database issue, only one farm would go down. So the other 75% of their users, they were not impacted. And that made the business quite happy. And this essentially served as the pod architecture in the VDI world. Right. So as soon as Citrix started debuting, Zen Desktop, our VDI product, and I remember VMware, right, when they started shipping View, all of a sudden you started seeing reference architectures appear, in our public documentation that had the word pod. And so that was really it. It was really similar to what we did in the the server-based computing world, or what we did with XenApp for forever. We just used smaller Zen Desktop sites, right? And I think Zeljko is going to talk about in a minute, right? Those might be 5,000, 10,000 per site. Because these are VMs and not, users, so it's a little bit different. But same stuff. We'd use storefront and web interface load balancing. We'd use NetScaler, ADC, GSLB, global server load balancing to, kind of make this appear transparent and seamless to the user. Even though behind the scenes there were lots of little pods or little sites or little farms that were essentially a scale-out architecture. So anyway, I could go on and on about some of the examples and details, but I want to drive home one point. Even the best architected systems, managed by the smartest engineers in the world, right? At Google, Microsoft, you name it, they will go down at some point. It might be a hardware failure like a disk and a blade. It could be a power supply I've seen even, but it could also be a software thing, right? Like the XML service black holing was a popular one. Or even in I think what we've seen in the last couple of years with public clouds, since a lot of our services start to reside on things like Azure, AWS, or GCP or whatever, even a fat finger, right, or human failure can take down some of the largest, best architected systems in the world. So, that's essentially what we're doing with the pod architecture. I like to think of it as a smart hedge against, all these different types of failures that can and will occur. So I think that's a good segue to the next slide. And this is one of my favorite pictures, I think, you'll see here. This is you might not know what it is, but about 10 years ago, my New Orleans Saints played in the Superdome. It was a home game. And this is when, if you remember, the lights went out. I think it was like at halftime or third quarter. But literally, one of the biggest events on the planet. You spend all this time preparing, and I'm sure they had plenty of nice design plans, and the power goes out. On the world's biggest stage with 100 million people watching. So, Yeah, so that's again why I think we do these pod architectures. It's just kind of minimize these potential risks and failure domains. So let's switch gears and talk about some of the considerations. So I think the first objection that always comes up when I start lobbying for a pod design is cost. Customers might agree and say, all right, Nick, that's all awesome. You sold on, the benefits of a pod architecture, but man, this sounds expensive. And yeah, make no mistake about it. I mean, having one giant CVAD site, it is, cheaper and, and it's the easiest solution to implement and manage, but cheap doesn't always translate into the best solution for a business, right? So I'm typically making the case to trade things like predictable performance and, better system uptime versus, the management overhead or a slightly increased cost, right, that a pod kind of entails. So that's the trade-off here. Will managing 10 SQL databases instead of one be cheaper or easier? No. But you'll thank me when, you only lose 10% of your user population versus 100%. So I always say that a pod architecture, it is a little bit more expensive. Yes, I'm not going to lie there, but it's really expensive for a business? Being down across the board, reverting to pencil and paper in a hospital, or making headlines due to a site-wide outage. That's really expensive and costly. So another consideration is around the size of the pods, or what we call failure domains, right, that I hinted at earlier. So I provided an example earlier where we use like 4 XenApp pods for 100,000 task-based workers. And I remember our first Zen desktop customer that pushed the limits of that product. We ended up carving them into about 10 or 12 sites with about 5,000 to 10,000 desktops in each site or pod. But how did we come up with those sweet spots? Well, it's a bit of an art and a science, all right? So the science is the easier part, in my opinion, and I think Zeljko and Michael will talk in a minute about proper sizes and some of those sweet spots. And the good news is a lot of those are based on quantifiable things, right? Like system specs or technical limits in the cloud. But the harder part, or the part we debate most often, is how many users is too many users to lose or be down at one time, right? So that's and there's no kind of hard and fast rule, right? Some organizations say that, I can afford a 10%, kind of impact, or 25%. And you've probably heard of rule of thumbs like N+1 or N+10% or N+20%. There's a million. But the bottom line is it depends, and I've actually recommended different failure domain sizes or thresholds for different implementations and customers. So I hate saying it depends, so let me kind of attempt to clarify what it depends on. Let's say customer A has unlimited cache, they're really great with PowerShell and automation, and they're running a mission-critical healthcare app. Then I might recommend more smaller pods to essentially protect that business and those workloads better. But let's say customer B, they're more cost conscious. They don't have great automation skills. They have a higher tolerance for risk, and their workloads, let's say, aren't mission critical. Then I might actually recommend a few less pods, right, to make the failure domains actually a little bit bigger. So it's kind of, I also think of it like investing. Everyone has a different tolerance, right, for risk, and one size portfolio certainly doesn't fit all, right? It's going to vary. And then the last consideration I'll touch on is what to share or not share between pods. And this is where, there's best practices in reality, I always say, and I get it. I live in the real world, and there's different teams and lots of different teams and enterprises, right, that manage storage and Active Directory and this and that. So sometimes you're going to win these battles, right, and sometimes you're going to lose these battles. But here's the rule of thumb. If it's likely to fail, put it in a pod. So it seems really simple. But I just told you, of course, that everything fails, so everything should technically belong in a pod. But, I guess what we try to do is go down each of these components with each customer based on their unique business requirements and figure out, what is kind of the best thing to do, to put in a pod or don't put in a pod. The first two you see there, PVS and SQL, these are kind of things that I kind of can't live without being in a pod. And the reason why is because they're kind of critical path is how I like to think of them. And with everything being database driven and like, kind of Citrix's architecture, with PVS, being that a critical kind of, heartbeat, right? So if that goes down, everything kind of goes down. Those are two things that even though, again, they might be expensive, and I get a lot of pushback on SQL in particular, and other customers will say that, well, PVS has offline database support, and SQL has, all these HA mechanisms, like always on availability groups. Yes, they do. They do. And we enable those things. But guess what? When you have weird issues like deadlocking or a service black holing, these HA mechanisms don't always kick in. And so that's why I really recommend putting these things in pods, because those two are really, really mission critical, and sometimes those things just don't kick in. Other things, right, that I point out here, like the access tier and user data. So access tiers, things like storefront, web interface, ADC, NetScaler. There does become a point where, like, NetScaler is a great example, or ADC. It becomes cost prohibitive to have a couple of hardware-based MPX boxes or appliances for each little pod that might be serving 5,000 users. I get it. That's not going to be a great use of resources, especially when the CPU of those boxes maybe serving 10, 12 pods could be sitting at 15%. So that's one where sometimes we might actually say that that's totally cool to live outside the pod and sort of serve up multiple pods. User data as well. If you architect those solutions correctly, right, things like profiles, right, and say that each little profile piece on a SAN or NAS can serve up 25,000 users, and you just kind of you do your own pod architecture for that. That's also fine to live outside the pod. So anyways, there's, if you think through all the different components, there's probably like 15, 16 components, right? These things like PVS and SQL in like your typical CVAD deployment. But the moral of the story is you got to go through these one by one and kind of figure out, what lives in a pod, what lives outside of a pod. So anyways, I could, continue babbling on here, but let's turn it over to Zeljko and Michael to walk through some of the technical kind of details. And then I'll be back to answer any questions you might have and talk about more examples. Zeljko, thanks.
Hey, Nick, thank you. Thank you for such a great opening, and thanks everybody for joining this webinar. So right now we're going to start with some of our design principles, and we're going to look at our 5 principal design layers. So let's start with the user layer. So once we start designing for the pods in a regular user, in addition to our regular user layer, topology, endpoints, peripherals, we really need to look it up at the limits. Like where can we stop? Where do we have to stop? And right now that is for the single session OS VDI, it's a 10,000 VDAs and within a single site, single zone. Once we start talking about published applications, you can push it up beyond 15,000 users, but I would recommend not. So design your pods to kind of fit within these limits. The fact that you can go this high, it doesn't mean you have to. So if you look it up into your overall design, when you look it up the number of VDIs, number of users, number of everything that you need, you kind of have to encompass all that into like, what does it make sense? So if I have, for example, 30,000 users, I may go with and plus, I don't know, 20%. I may go with 4 pods, 10,000. I also may go with 8 pods, 5,000. Again, depends on how much users do you want to, and how much impact do you want to make if one pod fails. So if you shift our attention, and that is for on-prem, if you shift our attention to the Citrix Cloud, and at this case, we're going to talk about Azure limitations by itself. So within a Citrix Cloud, you can host 5,000 VDIs, or single session OS VDAs, per single resource location. And that is the limitation. It will be up to the 10,000 VDAs sometimes this year, as long as the LHC limitation were addressed. And for hosted shared desktops or published app or multi-session OS VDAs, where if you're working in Azure, you can take the Windows 10 multi-session, you can actually just have about 500 those multi-session OS VDAs within a single resource location. Now, that is the Citrix limitation. Now we have to go into the Azure limitations, or Azure/Citrix limitations, when we get into like how many VMs per subscription we can have if we use the MCS. So right now the number is 2,500, but please check every time you do the design, please check these numbers, because they really change very often. I usually design my pod in Azure with the 2000. It really lines up very, very nicely with the /21 network. So, and these are just the limits. There are a lot of other stuff when you start designing. And then just talking about user layer in general, like all the regular iterations of the user layer portion of the design, you still have to do that, but these are just the limits. How much can we expand a single pod? And then again, just to make the point, the fact that you can go that big, please don't. If you don't have to, like that is the Nick's favorite question. The answer, it depends, and it is mine as well. It depends, as long as you know answer to that depends. Depends on what? Depends on the money. Depends on the scalability. Depends on the fact, like, how much impact do you want to make if one pod fails, if one region fails, if one subscription fails, or whatever fails. So for the next thing, not to take too much time on just the users, we're going to look it up in access layer. So once we start talking about access tier, we have quite a few options. Good thing is Citrix Gateway Services or Citrix Gateway in the cloud can only integrate with the workspace. And then that's good thing because we have other combinations that we have configured. The first bullet point, workspace for Citrix Gateway Services, it's really easy to configure, no maintenance, no management, no nothing. But in reality, it's very, very unlikely that you will use this for enterprise services, because these Citrix Gateway Services, as well as the workspace, have a SLA of 99.9%, which kind of equates to around 8 hours a year, which is just over a minute a day, I think, if I calculated that right. But still, when you go into enterprise and a minute a day means a lot of money to lose, then yeah, you have to consider other options. The other option that we see more and more is ADC plus workspace in the Citrix cloud. We still have that 99.9% of the availability or SLA of this workspace services. However, that only impacts the people that are trying to log in. Existing sessions or existing users that have a AGX or ICA session through the ADC will not be affected if the workspace is suddenly unavailable. And the last option here is the ADC plus the storefront, be that installed on the Citrix cloud or on-prem. It really makes not much difference because you have to size them properly both sides. And this is what we hear, what we see for most of our enterprise customers. One thing, when you start going with the ADC and the storefront, especially if you're in the cloud or if you're doing the multi-zone, even though when on-prem and I'm doing just a CVAD, I try not to do zones because it does complicate. I'm already separating sites. Why would I put my zones in? But if you're dealing with the cloud, make sure that advanced health check is on, and that is the web.config file configuration that will actually allow LHC to work properly across multiple resource locations. I'm not going to go into that. That might be another webinar just to go over that. So this is actually one of our customers. And what we wanted to do is to show that access layer integration within a pod or not getting integrated within a pod. So I hope you can see what's on this diagram. So you have we have 3 pods per data center, and those pods are identical. The user actually authenticates internally just on the storefront servers, and their OGR back through the internal gateways. Those internal gateways are just VPXs on a big box, big SDX box. In this case, you can see we kind of lined up our pod infrastructure with our access tier with the pod infrastructure. But if you look it up into external user workflow, they can hit either data center. And our access layer for external users is actually not lined up with the pod, but only data center, because they're sitting in the same data center. When I want their ICA session back, I'm just going to pick the right data center for external work. So again, it depends how you're going to design your pod environment. But you can see that even within a single customer, we have store or access tier aligned and not aligned in the same architecture, depending on the user workflow. So the next thing I also want to mention is the location of the file servers. Now that a lot of customers are moving to the identity-based authentication, the question comes in, do we align files with the pod or not? And then how do we translate all this in the Citrix Cloud as well as Azure? In this case, we didn't align Citrix files with the pod because it was the on-prem. We had our file servers located within a data center. We actually aligned file servers with the data center. So when you go into Citrix Cloud, especially when you have the resource locations, and right now you can actually use the file server for the multi-resource location. Again, keep in mind, like what is your failure domain? What do you want to save? And how much are you saving by if something fails and users can't log in or establish their session? The file server, I don't want to say is it's not going to break your session up. It's going to break your single sign-on, but still, not everybody knows how to. The users will usually just flood the help desk and say, "Hey, I can't log in. Something's popping up on my screen." So, how you're going to design that? Again, I'm going to go with Nick's or my favorite answer. It depends, but it depends on many other things such as latency, the speed between the data center, the locations of the Azure regions, etc. So the next thing is the resource layer. Nick already mentioned before, like how do we deal with user profiles? So we need to define how we deliver these user profiles to users. The first question we have to answer: are we designing for a single production data center that will host multiple pods or multiple resource locations if we're talking about Citrix Cloud, or not? If everything is in a single data center, that your answer is easy. Yeah, fine. I'm going to put file share, any file share, and put my profiles in. Now you have several options. What do you want to do? We usually lead with the Citrix Profile Management and then CPM or FS Logic. Those are kind of leading practices right now that we have that are included within existing licensing that you have with Citrix or Microsoft. If you have a third party such an Ivanti, yeah, that's fine. Just go use Ivanti across the board. So what happens if we see the multiple data centers or multiple Azure regions? So once we go on-prem, that really, if you have a multiple data centers, then you will really have to do homing users to a data center if you're using the either or profile management or FS Logic. Home users to your data center, make them home data center, and just let them go through it. If you're going into Azure, there is a decent option that you can use, Azure FS Logics and Azure Cloud Cache. That will allow for some high availability of your FS Logics profile solution. But again, you still have to look it up at the limits. And in this case, the limits would be on the Azure files or Azure NetApp files. What is the price difference? Azure files are cheaper, but they have some limits. Azure NetApp files, yeah, if you can live with it, good. The price is a little bit higher than just an Azure files, and the performance is a little bit better. Now, when we start talking about resource layer, we also talk about images. So you have a pod architecture. You already have 4 or 5 or 6 pods, or you have several subscriptions that you want to use in Azure, and you want to limit the number of images. Ideally, you want to have 1. Not realistic, but you want to minimize the number of images that you want to manage. And that comes in a question, and I think Mike is going to cover that a little bit. Do we align our PDS with the pod or not? And what happens if we don't? And what happens if we do? So the number of images should be minimized regardless of the method that you are delivering those images, be that PBS, on-prem or Azure, or MCS. And also designing for pod will really, we always talk about separation. We always talk about like, we want to separate our infrastructure service, our VDA workloads, and even within the VDA workloads, we want to separate our desktop OS VDAs and the server OS or multi-session OS VDAs. So that is the same principle applies with the pods. It's a predictable. You know the load. You know what's going to happen if you only have if you have a pod and you do the VDI and the server OS VDA, VDI and the server OS VDA. And if you're in the need to have multiples of desktop OS VDAs and server OS VDAs separate and keep them separate, again, images gets into the picture, and then you want to maintain all those number of images available to your use. Now at this point, I'm gonna pass the stage to Mike Shuster, and thank you everybody for joining.
All right, thank you, Zeljko. Thank you, Nick. It's gonna be a tough act to follow, but we'll see what we can do. So let's start getting into some of the fun areas, not that everything else wasn't fun, just about how we architect our control layers and considerations there. So if we're dealing with delivery controllers or cloud connectors, these tie into some key things that we need to keep in mind. Number one, as far as a pod building block goes, if we're using on-prem, each pod is going to have its own Citrix site, not a zone, but a site. The idea with the pods, again, is that we don't want to be sharing many components between them, so a zone architecture for on-prem is not appropriate. It's a bit different with Citrix Cloud because of all the secret sauce behind it in the back end there, but nonetheless, with cloud, at least we can scale out to a certain point. We'll talk about that a bit later on, the number of resource locations that we would use and shore those up within a pod, keeping in mind the limits that Zeljko went through before. Always want to make sure we accommodate for N+1 or N+2, and if we're dealing with Citrix Cloud across our pods, we should look to stagger our resource location maintenance cycles a little bit, just to make sure there's not a lot of overlapping maintenance activities happening amongst your resource location at a given time. So another thing for us to consider as far as our pod and zone architecture here, zone, i.e. cloud specifically, is how we're going to deal with subscriptions. So here's the deal. Citrix Cloud continues to push the limits in terms of how many concurrent sessions and we can be supporting at various scales, 100,000, 125,000, blah, blah, blah. But in reality, we want to keep in mind, especially in the spirit of pod architecture, which is, again, is looking to compartmentalize the number of components within a given group of users we're supporting to help manage failure domain risks and blast radius considerations if something were to fail. So with that in mind, depending on customer risk tolerance, if you're dealing with 100, 200,000 users that we're designing for, we may want to look at not necessarily trying to hit the upper limits of a given Citrix subscription, but perhaps carving them up into maybe a maximum of 25,000 users per Citrix Cloud subscription, or 50,000 users, and so on. Does this add a bit more management overhead? Yes, although some of that can be reduced to some degree. There can be some back-end things that can be done to help aggregate various control planes together to some extent, just to reduce the amount of pain that having multiple Citrix subscriptions would necessitate. But depending on your scale, it may be necessary to go a multiple subscription route regardless. Talking about SQL next, so definitely need to make sure that we have a separate SQL deployment per pod, and we're not sharing SQL across pods. We want to make sure that the SQL environment sized appropriately for all the databases in scope. For example, if we're adding in WEM, we really need to size our PBS or our SQL servers to accommodate for that, but site and PBS databases are not as critical. And PBS obviously is going to be a requirement to have SQL, so nonetheless, want to make sure that we're dealing with SQL servers dedicated per pod, and they should be in HA configuration in the environment. So PBS is another fun one for us to deal with. PBS, just as Nick has mentioned, we want to make sure that we are using one PBS farm per pod, not one PBS farm with multiple sites. Multiple sites would be a consideration in maybe some other context or whatnot, such as Azure. We'll get to that in a second. But from a pod architecture perspective, we really want to look at making sure that we've got one PBS farm per pod. How many targets can we support, and how do we size our PBS servers? Well, here's the thing. PBS in of itself, a PBS server is exceptionally scalable. Depending on the targets that we're streaming to, the behaviors of boot storms, available hardware, this and that, the upper limit of PBS that engineering is comfortable with is about 3,000 target devices per PBS server, although I can say in the field at scale, the consulting organization will typically trend around 1,500 to 2,000 as a good place to land. So for the sake of math, in our pod architectures, 2,000 target devices per PBS server is a good target. We need to make sure that we tune our hardware appropriately for that in terms of the amount of vCPUs that we use and the amount of RAM that we're using, depending on the number of V disks we're going to be streaming, so on and so forth. But the number, whether we use 4, 8, or 12, or 16 cores in our PBS server is only going to depend on how we need to deal with boot storms to a degree. Because once a PBS target device is up and running, there's not a lot of load on the PBS server. But when target devices are booting, there's a lot of load on the PBS server's compute resources, specifically CPU, that we need to consider is all. So that's a sizing consideration. We also want to make sure that at scale we're following our regular procedures, like making sure we're tuning boot pacing from defaults and things like that. If we also want to make sure that we're accommodating for an N+1 configuration, so about maybe 6 PBS servers for 10K VDIs would be streaming is a good place to land if we're on-prem. Azure is a consideration here for PBS because that's a new feature that is now out, and a good place to land is still about 2,000 VDIs per VDI or subnet, and a pair of PBS servers for each, although there's some considerations there we'll talk about. PBS in Azure has been tested at about 2,500 streams, target devices, and that aligns to like the current limits anyways on a subscription anyways as far as VM counts. And Citrix prefers generally to go no larger than a /21 subnet, which is about 2,000 VDIs or IPs. Yeah, okay. So with that in mind, even though you could go 2,500, probably good to stick with our guidance of like a /21 and scale it that way. So 2,000 VDIs per subscription in Azure, a pair of PBS servers that are servicing up those VDIs in that subscription. But we'll talk about that a bit later on as well, in terms of how do we carve up our PBS, because there is another way of doing it in terms of how we position our PBS in Azure, and we'll talk about that a little bit later. One key thing though, be sure if we're doing PBS in Azure that we enable accelerated networking. And might as well talk about that other thing now, actually. So there's two ways that we could do PBS in Azure at scale. So either we've got a pair of PBS servers in each of the subscriptions that we would do, and that's all well and good, and it's probably the simplest, but you will end up with more PBS servers than maybe you need. What we could do alternatively is have in a hub and spoke model, and we'll talk about that in the compute layer, but if we have adopted a hub and spoke model for our Azure environment, we could throw our PBS servers in a designated subscription and have PBS servers set up to handle the streaming for all of our locations up to maybe, let's say, the 10,000 limit that we're talking about as an example, as a suggested point for max number of systems per within a pod. And doing that, we will end up with fewer PBS servers that we need, and then we just do some VNet peering to connect the PBS server's subscription and its VNet out to the various subscription VNets where our VDI target devices are sitting. You could go that way. So it's a bit more complex on the networking backend, but it is doable, although you will be sacrificing in terms of more failure domain isolation to a degree, because in the other model where you've got PBS servers per subscription, you've got 2 per subscription, which is a good level of availability. This case, you're sharing more of those resources together. The engineering team has confirmed that even the load that would be putting on the VNet peering for streams at scale here shouldn't be an issue. The Azure backend networking should be able to handle it fine. Let's talk about Director. So Director, because it's not a mission critical component, and really it doesn't really rely on a lot of backend systems like individual SQL database that it's running and this and that, it's easy enough to say, listen, we'll have a Director server per pod and just do GSLB or something in front of that for availability, and then configure our directors to integrate with all of our on-prem pod Citrix sites. Now, if we're dealing with Azure, it's not really a big deal because that's all going to be found centrally within that one aggregating everything from all the different resource locations. We don't have to worry about any complexity there, deploying servers for that. And if we're doing a multi-subscription setup, there may be ways for the cloud engineering team in the back end to help aggregate some of those pieces, so you can centrally review the metrics and data of your aggregated Citrix subscriptions. Now onto WEM. WEM's another consideration, especially if we're dealing with on-premise to Citrix. This one can get a bit hairy. If it's not critical to what it's doing, you likely get away with a WEM deployment spanning all your pods. But again, keyword here being is criticality. So if we're not doing anything significant where PBS worst case went down and it's somehow going to impact users to be able to do any meaningful work, then that's a consideration point. Otherwise, you could do a set of PBS servers per pod. Each WEM server can handle about 3,000 users. So if let's say a pod of 10,000 VDIs, we're looking at about 5 servers per pod, including N+1 for WEM. SQL size and considerations there, of course, as well. Just keep in mind that with WEM, there is about, I think for every 3,000 users, something you have to have like a gig of memory to your SQL systems or whatnot. So that has to be included as well. And then if we are dealing with different, an isolated WEM deployment per pod, we'll have to make sure that we're replicating our configuration sets and keeping them in sync across the pods to make sure the experience is consistent across the board. WEM service, however, is easy. Most of these considerations go out the window because it's cloud hosted, really nothing overly difficult for you to deal with. On to licensing, one Citrix license server should really suffice still for everything. As you've got that grace period to rely on of 30 days if something were to go belly up, more than enough time to rebuild. If you want to get fancy, you could check with EULA and your account manager and see about using a multiple Citrix license server deployment on premises with an active passive load balance configuration set up. I have heard of customers that were successfully able to do that without breaching any agreements. RDS licensing, if we are doing, the pod architectures are usually more focused on VDI deployments, but these certainly apply, and the number makes sense. The numbers would be a bit different, but they still make sense, and the rationales make sense if we're doing hosted apps on server OS VDA. So in that model, one RDS server licensing server per pod. If we're going to have multiple server OS hosted shared desktop pods, if we're only having one because maybe it's a fringe group of application delivery that is not aligned to the majority of our use cases, which is really VDIs, then maybe they just sit in their own pod and just make sure that we've got multiple RDS servers there as well. Contrary to popular belief, RDS servers do not have the same grace period as Citrix license servers do. You really need to make sure you've got redundant RDS servers to avoid failures and outages for your users if they go down, and make sure that all your server OS VDAs can talk to all your RDS servers. And that's true whether we're dealing with device or user licenses. Last thing we want to talk about here is, two more things I've got to talk about. So Active Directory. So number one, key point, make sure that we are using separate service accounts per pod. This includes ADCs for LDAP authentication, anything like that. We don't want to share components. If we've got a service account that's shared across multiple, even for your hosting connections or whatever, and it becomes locked out, deleted, compromised, whatever, you've impacted the integrity of your pod architecture across the board. So use separate service accounts for each. Exception would be WEM here due to the SPN limitation, so it's really just going to be one service account. Do organize your VDAs into a pod-centric OU architecture as well, and please make sure that you've got enough AD domain controllers to handle logon storms, that we've got your AD sites and services set up properly. At scale, you may even want to consider having separate domain controllers for your various pods to make sure that during boot storms and logon storms or whatnot, there's sufficient capacity there to handle the incoming load. Next up is Microsoft CA. So we need to accommodate for scale as well, especially in large scale deployments that are using Citrix FAS. So consider spreading out your CAs one per pod, and then making sure that all FAS servers can integrate with them. This is both for HA and for performance as well. And that wraps up our control. So I think we can pop into our compute layer now. All right, so let's talk about Azure. So, so there is some limits with Azure that we've got to be mindful of. The key thing here being, as Zeljko mentioned, they do change all the time. So we want to be considerate of the 2,500 VMs per subscription right now, but not, again, as mentioned before, not bad to align to about 2,000. It's ideal in this case as well to align to like a 1-to-1 VNet per /21 subnet being a good place to land. and hub and spoke topology. So in large, actually in most enterprise Azure deployments that I personally dealt with to date, the customers are usually adopting a hub and spoke model, where in the hub you've got all your core infrastructure that are shared across your various subscriptions that might be used for different use cases, different business units, departments, or whatnot. And the same would apply to Citrix, where we can put within a shared or dedicated subscription for Citrix as the hub, all the core infrastructure components. And then in the spokes, that's where we'd actually have all our resources, our various VDAs and whatnot. We talked about the PBS consideration as well there. So that's a consideration. Where do we put PBS, in the hub or in the spokes? There's some trade-offs there as I outlined. On premises, there's certainly some considerations that we need to be dealing with. So number one, VMware, because this often gets missed a lot, and there's not a lot of, oh, sorry, we had a diagram to go through. So sorry for that. So let's go back to that diagram there. So here's an example of a deployment where we've got a infrastructure subscription, our hub, and then we've got various subscriptions that have our various sets of VDAs in them. But our core infrastructure is located in the hub, including cloud connectors, all those other good things, and then the spokes are just our individual subscriptions containing just our VDAs there. And then we can move over to the next slide there. Thanks, Amber. All right, so onto our on-prem model. So first and foremost, as I mentioned, VMware and vCenter, that often gets missed because it's a bit of a blind spot for a lot of folks. How many VDIs should I put on my vCenter? And that has changed over time. Back when I was doing Horizon View designs back in the day, the number was 2,000 max and then 3,000. With a properly sized, like X large or large vCenter instance now, we can do about 500 VDIs, and that would be the recommended upper threshold to land. We have to remember that regardless of whether we're using MCS or PBS, when we're dealing with pooled VDIs, they do put a lot of load on vCenter, which is why Citrix has always advocated, even VMware has always advocated for dedicated vCenter servers. It's not just to separate from production and reducing risks of shared infrastructure, what have you. It's also because the load of continually rebooting VMs, so we go back to this immutable image, keep the VDIs clean. That puts a lot of load on your vCenter server, so it's important to have them dedicated. So if you've got a pod of 10,000 VDIs, you've got two vCenter servers that need to feed that environment. If you're more risk adverse and want to keep that at 5,000 VDIs per pod, no problem. 5,000 VDIs, one vCenter, or consider even doing vCenter HA as well. Also important, do not deploy your hosting connections, integrate with your vCenters and set it and forget it. Not to be overly Ronco here. You do need to make sure that at scales like this, that we are tuning our hosting connections to handle it, so we're not needlessly throttling our systems. I've seen many an environment deployed with vanilla hosting connection parameters, and during reboot storms after an outage or whatnot, VMs are coming back very slowly or crashing during load and causing user issues or whatnot, because and the speed in which things are coming up is really because the default configurations in the hosting connections are going to throttle the connections in terms of how many actions it will take per minute and what have you, how many concurrent actions. So especially in these larger vCenter specs, we want to make sure that we ratchet those up so that we can perform well and take advantage of the appropriately sized vCenter servers that we have in our environment. Hardware separation. So this is something else we need to talk about. So do we share one infrastructure cluster for all our pods that we put all our storefront servers, delivery controllers in, yada, 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 or do we do it on a per pod basis? So this is a key consideration point because there is cost considerations, and generally it's going to come down to how risk adverse the customer is. It's the same thing with access tier. Do we have an access tier as part of the pod, or do we keep it out of the pod and it's shared? One is simplifying things, the other is going to make it more expensive. But generally, the more expensive trade-off is, again, we're reducing our risks and the financial impacts or business impacts that could result from an actual outage. So here's the rub on this. Generally, if we're asked for a recommendation, this is Ferroque and Citrix, we're going to recommend to customers to have separate isolated infrastructure control clusters per pod. So maybe that's 3 or 4 servers, depending on the host specs, that host that pod's PBS servers, delivery controllers or cloud connectors, storefront servers, blah, 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 blah. And then we keep that separate, of course, from the VDI workloads or any of the resource clusters that we would have as well, but it'll all be managed by the same vCenter. On that note, it's important for us to consider spreading hardware across racks to minimize failure domains, just like we would in Azure, spread as many things across our availability zones as we can, so we're not impacted so much by maintenance that might be happening on the data center floor, whether planned or unplanned, that could cause some downtime anyplace. Cluster sizing. So these recs have changed over time, but a good place to land for pooled VDI or host and shared desktops would be about 12 to 16 hosts, although Nick may have an opinion on maybe ratcheting that up even since. But it's not a bad place to land, and also make sure that we're sizing for N+1. VM host density is going to vary based on how many clusters you might need, depending on the hardware that you have. And again, sometimes customers may prefer to go with more smaller hosts and have more clusters than they would have fewer clusters with large honking hosts, just because, again, it's great that you may be able to shove 200 VDIs on a single host, but do we really want to tolerate impact if that entire host fails? Customer risk tolerance may prefer using smaller hosts and maybe keeping density closer to 50, 100, 150, whatever the case is, to help balance the risk to a degree. As far as our subnetting goes, generally speaking, keep it the golden rule of one VLAN, one subnet, /21 maximum would be the recommended approach to take. But if you would prefer aligning to a /22, that's okay as well. But just keep in mind when we start dealing with PBS, although you can stream PBS traffic, never stream it through a physical firewall. You will not have a good time. Do not do that. But if there's no firewalls in place between your VDIs and your PBS servers, you can route that traffic, but then you are adding an extra hop and maybe saturating bandwidth on your router to a degree, or your L3 switch. So if you can, /21 aligns nicely with the PBS streaming considerations I talked about before. But once again, you could go ahead and stream and route the streaming traffic if you'd like as well. Storage. So this one's a bit of an interesting point, but generally, if asked, we're going to recommend having a separate SAN for our pods. If you want to use vSAN, that's a different discussion. That's going to be on a per pod, per cluster basis anyways. But if we're talking about storage and storage networks or whatnot, one storage device per pod. Keep it set for the rest. It might add more overhead because now we're managing more hardware, but it is what it is. I'm going to skip over file services because we could probably spend an entire webinar on that, especially at scale. So we'll take a quick peek at another diagram here just to look at another on-prem deployment here as well. So with our various access layers, our subdivided control components here, and our various pod clusters here. So in the middle, this is an example of a 10,000 seat pod. We've got 2 vCenters, got 5,000 VDAs in each. So each cluster is destined to support about 1,000 VDIs. Just need to make sure that the specs of the hardware align to that. And there you go. With that, I will hand it over to my colleagues to close this out.
All right. Okay, so that was very, very insightful, and we have some questions from the audience. Number one, we have a question saying, asking the on-prem SQL goes down. We have LHC, Citrix Cloud goes down. We have cloud connectors. We have service continuity, and so the cloud conversation sounds like a bit of a counter argument. So can you speak why the pod would still be needed over the existing solutions and protections? I think that's a big question.
Yeah. Nick, you touched on that earlier. Do you want to follow on with that?
Sure. Well, yeah. So, I mean, the first thing is, got to hype up service continuity at all times. So that's still a relatively new feature in Citrix Cloud, but one I'd been lobbying inside of Citrix internally for about 4 or 5 years now, since I was a big LHC guy. Because again, I just think that, and I've seen it happen firsthand. It's not a matter of if, it's always a matter of when, and you're going to go down. So, service continuity still has some limitations, but it's, I think, been out for about a year, in the public kind of GA world. So that's kind of the first thing. But the other thing I'll say is, like, even if you implement service continuity and, like, say your use cases are supported under service continuity, we still I mean, not only Citrix, but again, all the hyperscalers like Microsoft, Google, whatever, we do a really good job of masking sort of the pod architecture behind the scenes. So that's number one, is like, just because you think it's in the cloud that you don't do pod architecture, that's totally wrong. It's that everybody in the cloud, public cloud, is doing scale out pod architecture. You just don't see it. The other thing I'll say is, a lot of people don't know this, but like our largest Citrix cloud customers, right? So I'm not talking on-prem. Citrix cloud customers, even with workloads in public clouds, we actually, because they're scaling to such high levels, and we're again reaching those, we're just encountering those like weird, unpredictable consoles taking too long, like I described earlier. We actually have like some of our biggest cloud customers in multiple tenants because of things like analytics or director or whatever. So even though, again, behind the scenes, like Zeljko said, you don't have to do zones and all these things that we used to do on-prem. We kind of do that for you in Citrix Cloud. But we even still, outside of like subscriptions, we actually might have like our biggest customer in like 5 different tenants, like Citrix Cloud tenants, and we just put them together and make it look like it's seamless to the end user again. So, again, just because it's cloud doesn't mean that pod's out. Pod's still in. And I think, if anything, the hyperscalers do a hell of a job of doubling down on kind of the scale out pod architecture we just talked about. You guys have anything to add on that?
Yeah, just one minor thing, although it's more the on-prem side of things. I didn't touch on it in the SQL section. The other reason, especially on pods here, we're doing pooled VDI and all that great stuff, is LHC does not help you with pooled VDI. The reason is because LHC does not contain the hypervisor connection details. Now, LHC in Citrix Cloud, it does. That's a fairly new thing, but it's just something to consider on-prem, which is another key reason why it's important to keep your SQL servers isolated on a per pod basis to overcome potential risks related to that.
All right, we got one more. So what is the best practice these days for sizing in the cloud? I think you used to recommend scaling up on-prem with bigger VM sizes, but now does that change anything with sizing it in Azure?
Yeah, let me take a stab at that one, because this is like, I have to raise my hand and say guilty, but it's not guilty. I just like to say, I cover my butt by saying best practices evolve. So I used to have this slide I love presenting on scalability, but like I used to have this slide that said, I think it was go big or go home, was like the title of the slide. And what I was trying to like preach, on my soapbox to customers, partners, anybody that would listen, was like, don't just kind of follow old habits and use these VMs that are 2 vCPUs and 4 vCPUs that are really small. What I was trying to say was, within the confines of like, the hardware, right? There's a certain number of cores, and there's also NUMA, like nodes inside that hardware. Like, go as big as you can inside those NUMA nodes with that hardware, and like stop there. So basically, I was saying, like, don't be afraid to go with 10 vCPUs, 16 vCPUs, 32 vCPUs, even on some of these monster boxes. Of course, fast forward to the cloud, everything changes, right? Because now it's, you have to play this game between, it's like you don't own the hardware asset, you're paying for it in real time per hour, right, per minute. So it changes a little bit. And I used to say, let's talk Azure for a minute, just because, it's kind of maybe more familiar to all of us. But like I used to say, go with the compute optimized F series, right? And I really liked the bigger ones. So I'd say these F16s, and F is basically for 16 vCPUs, you get double the amount of memory. So it's 16, 32 gigs of RAM. And then, some of my colleagues would of course be like, oh, the Ds are better because we won't need more memory. And I'm like, yeah, that's true if you need more memory. And of course, with browsers and things that eat up memory, Ds, the way to go. But if you look at the price, which is what it comes down to, it's not just about capacity. You got to look at the price and kind of do the math, and these things change all the time. But if you look at Azure East Region 2, and you look at F versus D, it might be the same cost. It's actually really close. I think I was looking at it the other day. It's like 0.78 versus 0.81. I mean, it's so close that sure, give me the D with the same specs, and then you get a 4-to-1 ratio actually of memory to CPU instead of 2-to-1 with F. But the long story short is, I'm definitely recommending, I'm more open to D because the prices come down, and I'm more open to smaller VMs these days. So Microsoft actually recommended their guidance on like RDS, Azure instance sizing like 4 months ago. And whenever they come out with this, I gobble it up like the same day and read all about it. But what they said was, we now recommend between 4 and 24 vCPUs. However, once you go past 16, the synchronization overhead typically, makes the ROI negative. And then for their light, medium, and heavy workloads, they actually said we recommend about 8 vCPUs and 16 gigs of RAM. So they literally just told you to use F8. Like that's what an F8 is. It's 8 vCPUs and 16 gigs of RAM. So that's kind of the sweet spot these days is, you know, don't go as big as you can, right? Because, you know, maybe you can use some D8s or F8s and use auto scale and power those things down easier because we still have the drain problem, right? No matter on-prem in the cloud. But anyways, that's my long-winded answer of saying like I'm more open to going smaller and scaling out with like something like D8s or F8s instead of like F16s or, you know, something bigger.
And also, I'm going to jump in just quickly. Look it up at the sizes. Some of the Azure sizes actually have a temporary disks attached to it. So, and you're using MCS or PBS, you're already attaching an extra disk, especially if you go MCS plus MCS IO. So look it up at the sizes because you don't want to pay for the feature that you don't use. The good thing about those temporary disks, they're not big, and by default, the page file goes on there. But again, just look it up at size.
Yeah, half the battle is staying up on top of you know, all the different, you know, hyperscalers costing and what, you know, what are the different instances. Like now, I was just looking like, oh, there's, you know, FSV5s or whatever, DSV5s are out. You know, it's all about basically the newest Intel processor and then AMD as a counterpart. So you got to look at all of them and stay on top of the stuff on a weekly basis because even the prices by not only instance but by region differ. Right?
Yeah, it's a part-time job in itself. One thing I want to mention before we wrap up is this presentation is being expanded upon in a Citrix Tech Zone article that we're all collectively working on. So stay tuned in the next few months. We'll get that out the door as fast as possible because it's about time, again, as Nick mentioned, we got pod being mentioned throughout these various Citrix docs for the last decade, but no actual definitive document of it. So I figured we'll just get it done. So here we are, is what we're doing.
Yes, and pods aren't dead. Just because we have the cloud doesn't mean pods aren't. Pods are alive and well. We just do a better job at hiding them, I think, is the moral of the story.
Tiger hidden pod.
All right. Well, thank you, gentlemen. Very informative session. Really appreciate your time in building and helping put together the presentation and sharing all this valuable information. And a special thanks to our audience for taking time out of your busy schedule to join us today. We will be posting this webinar on YouTube in the coming weeks. In the meantime, we have a whole bunch of other videos on there, one of which we just posted a couple of days ago, which was an interview with Mark Templeton that we did over the holidays. So be sure to head on over to our YouTube channel and take a look at that. Otherwise, have a wonderful day. We'll talk to you guys all later. Thank you so much.
Thanks all for joining us. Thank you.
All right, thank you.
Thanks.